So yesterday we did inverses, and today we're going to prove that functions with that are inverses by what's called compositions. Okay. So let me move this up here so I can see it. All right. So if two functions are inverses of each other, they undo each other. Okay. So the composition of two inverses will always result in an x. So if you get an x here, sorry about that. If you get an x right here, when we do the inverse, when we put the function, the inverse function in the function, then in both ways, then that's when we know that the functions are inverses of each other. So this is what we call a composition, right? So we've done these before. So what we're going to do is we're going to work a couple of them here so you guys can see. So we have an f of x and a g of x, and what we want to see is, are these inverses of each other? So what we're going to do is we're going to take our g of x right here. We're going to put it in for that x of our f of x. So we're going to go 1 over our 1 over x plus 1. And see that minus 1 right there? Minus 1. Okay, so what is 1 plus 1? Plus 1 minus 1. So these two do what to each other right here, guys? Cancel each other out, right? So that's going to be 1 over x. Would you remember that 1 over x is x to the negative 1, right? So this is going to be 1 over x to the negative 1. Well, if something's in the bottom, it's really what? Yeah, so this is going to be 1 times x to the minus 1, which is what? X to the first, which means it's x. So doing f of g of x proved that we got they are inverses, but we have to do the other as well. So let's do the other one as well. So now we're going to put our f of x, this, in for that x, okay? So that's going to be 1 over x minus 1, and then we're going to add 1 to that when we're done. Okay, so if you remember, we keep, change, flip, right? So we're going to keep our top, we're going to change the bottom, and multiply. So that's going to be x minus 1, so we're going to change it to put the bottom on the top and the top on the bottom. So anything over 1 is 1, right? And anything times 1 is what we had. And then we're going to add 1 to that. So that's going to be x minus 1 plus 1. So what's our answer? It's going to be x again. So we have to check it both ways because sometimes it'll work one way but won't work the other. So because we got x for both of these, then we can prove that these are inverses of each other. So for example 2, we're going to take our g of x again, this whole function right here, and we're going to put it in for that x right there, okay? So that's going to be 3 times our 1/3 x plus 1 minus our 1, okay? So 3 times 1/3 is 1, so that's just going to be x, and 3 times 1 is 3. So notice this time we got x plus 2. So we did not get an x. So we don't even have to do the other one, because if even one of them doesn't work out, then we can say that these are not inverses of each other. Okay? All right, so let's do this next. You do these next two and come back to me when you're done. All right, so on this first one, I'm going to do f of g of x. So I'm going to put this function in for that x right there. So I'm going to do 2/3 times 3/2 x plus 9, and then add a 6. So notice the 2/3 and the 3/2, they're inverses of each other, right? So they cancel each other out. So we just get x when we multiply those. And then 2 times, remember this is 9 over 1, 2 times 9 is 18. 18 divided by 3 is 6. So that's plus 6 plus another 6. So what do you notice already? So this is x plus 12. So these are not inverses again because we did not get an x. Okay? All right, let's try this other one. So pause me here, come back when you're done. Okay, so what I'm going to do again is I'm going to take f of g of x. So I'm going to take this and I'm going to put it right there. So that's going to give me 3x minus 2 plus 2 over 3. So those 2's are going to cancel each other out. So that's going to give me 3x over 3. 3's cancel out, so I'm just left with x there. Okay, let's check it the other way. Let's now do g of f of x. Okay, so now this time we're putting this in for that x, right? So we're going to say 3 times x plus 2 over 3 and then we're going to subtract the 2. Okay, so what happens to those 3's? Isn't this 3 over 1? Yep, you got it. They cancel each other out, right? So that's going to be the 3 cancels the 3. So we're just left with the x plus 2 minus 2, and the 2's cancel each other out as well, so we're just left with x here. So these two are inverses of each other. It checked out both ways. All right, let's see if you got second thought. So we're going to do example 3 together, and then you guys are going to do the you try 3, okay? So what we want to do with this one again is I'm going to do the f of g of x, f of g of x, right? And that equals, so we're going to take this function, right, and we're going to put it in for that x, okay? So that means we're going to say 5 times the square root of x over 5 plus, minus 6, because that's my whole function, right? Minus 6 right there, all of that. Then plus 6, and then we're going to square that, okay? So what happens to those 6's? Yep, they cancel each other out. So we have 5 square root of x over 5 squared, right? So what happens to the square root? It cancels out, right? So then we're left with 5 times x over 5. So that's 5 over 1, right? So what happens to those 5's? They're inverses of each other, right? Sorry about that. So they're going to cancel each other out, the 5 and the 5. So we're left with x. So one of them checks out. So let's check it the other way. So now we're going to do g of f of x. And that's going to be equal to, now this time we're going to do it the opposite way. So let me erase this so I can show you what we're going to do. So this time we're going to take this whole thing and we're going to put it in for that x right there, okay? So we're going to do the square root of 5 times x plus 6 squared over 5, and then what? Subtract 6 from that. So notice those 5's in the numerator and the denominator, they will cancel each other out, right? So then we're taking the square root of x plus 6 squared, right? And then subtracting 6 from that. So what you should know is that this cancels that. So we're left with x plus 6 minus 6. Obviously, those two cancel each other out, right? So we're left with just our x. So this one checked out. They are inverses. All right, let's see if you guys can do this last one over here. All right, so now we are going to do f of g of x. So we're going to take this function and we're going to put it in for that. So that's going to be the square root of x minus 5 squared plus 5. Okay, so when I square a square root, and we could use the box method for this if we wanted to, and we could do the square root of x here in the negative 5 and figure out what this is. That would just be x, right? And then negative 5 times this would be negative 5 square root of x. This would be negative 5 square root of x. And that would just be 25, right? So this is going to be x minus 10 square root of x plus 25 plus 5. Well, I can already tell that we're not going to end up with just an x, can't you guys? Because this can be x minus 10 square root of x plus 30. So these are not inverses, okay? Because we did not end up with just an x. All right, so I'm going to show you another way to do these graphically, okay? So we're going to go out to Desmos, and then I'm going to show you. So what I'm going to do with these three is I'm going to put them in here in Desmos, okay? So I'm going to put the first function up here. So I'm going to actually put that in parentheses. So I'm going to say 5 minus 2x, close my parentheses, and then divide it by my 9. So there's my, how did I get a 9 up there? Sorry, y'all. So there's my first function, okay? And then here's my second function, 9 over 2x, right? And then plus 5 divided by 2, right? Okay. So we could just choose some points here. At 0, we have 2.5, which means at 2.5, we should be at 0, right? Yep. So those look like they are inverses of each other right there. So what I want to do when I look at a function like this, if I want to do it graphically, then I can actually go up here and I can look at my tables, right? So I can look at both of these tables and I can compare my values. So at -2, I'm at 1. So that means at 1, I should be at -2, right? Is that the case? So sorry. At -2, I was at 1. So at 1, I should be at 2. Am I? No. So, okay, we did check out one value. Do y'all remember what I said? So we had this one value right here, right? That checked out. But do all of the values check out? So that would be, so if we were to put up here 2.5, so let's go down here and put in, actually let's just put 2.5 right here. 2.5 is at 0, which means 0, it's 2.5. But look at it 1. At 1 at 7. So if we were to put 7 down here, did we get, oh no, we got -1. Do you notice that? So these are not inverses of each other because there was one set of numbers that were opposite of each other, but all the rest are not. So look here again. If I look at -1, I'm at -2. But if I'm at -2, I'm at 1. Okay. So that's a great way to check it right here in Desmos. So let's check the second one and let's see if it is. Okay. So the second one on here was 5 over x plus 1. So 5 divided by x plus 1. So there's that one. And our other one was x minus 1. And I'm going to put this in parentheses because it's on top. X minus 1. It'd be great if I could type, y'all. Divided by my 5. So here again, I'm going to use, because it sure doesn't look like it is to me, guys, but I'm going to double check it right here by doing, again, my table, okay, of my functions, okay? So at -2, I'm at -5, so let's put -5 in here and see if we get a -2. No, we don't, okay? See that? At -1, I'm at 0.04, so let's just see if there's another value here. At 1, so let's, at 0, we should be at 5, which means at 5 down here, let's put 5 in here. Are we at 0? No. Okay, so by putting these numbers in here for opposites, we can see that they are definitely not inverses of each other. Okay, so let's check the last one, just in case it works. Okay, so this one's 3, and then we got the square root of x. And then this one is 1/3 x squared, right? Here again. This one looks like it could be, right? Doesn't it? All right, so let's double check it with our table function again. Okay, so here we go again. I'm going to put my table in there, down here as well. So at -2, well, let's just 0, 0, that works. Let's look at 1. At 1 is 3, so let's just put 3 in here. 3, is it 1? No, at 3, it's 3. Y'all see that? Okay, so now here's the deal with this one. Remember, the top one was our original graph, right? So the bottom one is our new graph. And where did the values start here? 0, 0, right? So this is getting bigger, which means the other ones should be getting smaller, right? Okay, so which one of these graphs is going to be the one that we're looking at? It's going to be the one on the left, okay? So let's just compare this point right here. That's 1, 3. So at 3, and yeah, I can already tell. Why? Because there would be -3 over here. Y'all got me? So yeah, these are definitely not inverses of each other, guys, okay? So, because again, at 0, 0 it works, but nowhere else does it seem to work, okay? All right, so let's go back. So this was no, and no, and no. Y'all see that? Okay. So now, application problems. If an object is dropped from a hot air balloon at an altitude of 500 feet and the object's height after 2 seconds can be modeled by h of t is equal to -16t squared plus 500, find and interpret the inverse of h of t, which is t of h. Okay, so I'm going to actually just make this an h formula here, and I'm going to go -16t squared plus 500. And I'm going to solve for t instead of h, okay? So what I'm going to do is I'm going to move, sorry, that should be a negative right there. I don't know why I did an extra dot. So I'm going to move the 500, so that's going to be h minus 500 equals -16t squared, right? Going to divide both sides by negative 16. And so now I got, so that's all gone. So all I have left is the t squared, right? So I'm going to take square root of both sides, right? So t is going to be equal to the square root of h minus 500 over negative 16. So part B says, how long does it take for an object to hit the ground? I should say round to the nearest tenth of a second. So obviously hitting the ground would be 0, right? So our h would be 0. So this is going to be t. Oh, and it asks us to interpret. Sorry, I forgot about that. So this time, what are we solving for? We're solving for time as a, yeah, it'd be great if I could write, y'all. I just can't write today. Function of what, y'all? Time as a function of height, right? That's what we're solving for there, okay? So this is t is equal to, so we got 0 minus 500, right? Divided by negative 16, and we're going to take square root of whatever that number is. So that's going to be, let's see, what did I get there? I think I got, when I did that, so that's going to be negative 500 divided by negative 16, take square root of that. So that was, take square root of 31.25. And when I did that, I got 5.6 seconds. Okay. All right. Part 3, or C, says if it takes an object 4.82 seconds to fall on the top of a roof, how tall was the building to the nearest foot? Now this time, it says height right up here after t seconds, so we're going to solve for the height this time. So that's going to be h is equal to, and we're just going to use our original formula, right? So that's going to be negative 16 times our time, 4.82 squared, and then we're going to add 500 to that, right? Sorry. So this is going to be, when I did negative 16 times 4.82 squared, I just did that in my calculator, y'all. I got negative 371.72 plus 500. So that was equal to 128 feet when I rounded it. Okay? All right, let's go to the next one. So in this one, it says, nurses carefully track the height and weight of infants to ensure, not endure, ensure that they are healthy as they grow. The average height in inches of a girl in the first 3 years of life can be modeled by h of a is equal to 3 square root of a plus 19, where a is the age of the girl in months. Find and interpret the inverse. Okay, so here again, so we had the height is equal to 3 times the age in months plus 19. So we want to solve for a. So we're going to subtract that 19. So it's going to be h minus 19 equals 3 times the square root of a. We're going to divide both sides by 3, right? So that's going to leave us h minus 19 over 3 is equal to the square root of a. Now, how do we get rid of a square root? You got it. Square it, right? So that means we're going to square this to get our a. So our formula is going to be a equals h minus 19 divided by 3 squared, okay? Now, what does that mean? Because it says interpret it. So isn't this age as a function of height? So this is age as a function of height. Okay, then it says estimate the age in months of a girl whose height is 35 inches. Okay, so if her height, this is part B on y'all's paper, if her height was 35 inches, so we're going to say her age is 35 minus 19 divided by 3. Well, 35 minus 19 is 16. Is that right, y'all? So this is 16 divided by 3. So, and then we're going to do what with that? Remember, we're squaring that too. I forgot about that. So that's going to be, I'm just going to go ahead and do that in my calculator. 16 divided by 3 squared. I got 28 months. Okay, and then we got part C, which was if a child's 16 months old, how tall is she to the nearest inch? So this is going to take us right back to our original equation, right? So, because we're going to solve for height this time. So height is equal to 3 times the square root of, it says, what, 16 months? We're going to put our 16 there, plus 19. So what is the square root of 16? So that's 3 times 4 plus 19. So that's going to be 3 times 4 is 12. 12 plus 19. So I'm pretty sure that that's 31 inches, isn't it, y'all? Okay, there we go.